Good afternoon.
Good afternoon.
I'm Phil Stinson from the Department of Classics, and I would like to welcome everyone this afternoon to our Digital Humanities Faculty Seminar Series. This afternoon, our guest speaker is Ted Underwood, and Ted is an Associate Professor of English at the University of Illinois at Urbana-Champaign, and he has a PhD from Cornell University. Ted's major interests are 18th and 19th century British literature, and of course, digital humanities. He is a proponent of text mining in large digital libraries and modeling literary concepts with so-called machine learning. His recent book, Why Literary Periods Mattered, Historical Contrast and the Prestige of English Studies, had a significant DH component. And this afternoon, his seminar talk title is Beyond Tools, the Questions About Interpretation that Link Computer Science to the Humanities. Please welcome Ted Underwood.
Hey everyone, it's a pleasure to be here for many reasons. There are people I know in the audience, and my parents went to KU a long time ago, so this is a fun place to be. The talk I'm going to give is sort of at a tangent to the term digital humanities. The term itself, I think, focuses our attention on information technology itself, on the digital, or perhaps on tools we might use in the process of doing digital research, rather than on any particular other discipline. And in some ways that's a good thing. In some ways information technology is something that brings us together. We all understand the computers on our desks, maybe better than we understand sort of alien human cultures in other disciplines. But I'm going to reorient my focus today and talk about those alien human cultures, especially computer science and some sort of related disciplines like computational linguistics, and argue that we actually do have something to gain as humanists from talking to them, so that we can understand technology not so much as a grab bag of neat tricks, but as a set of intellectual traditions or models, different way of approaching it. And actually, because it's such an interdisciplinary talk and about contact between disciplines, I'm curious about where you guys are coming from. So, how many historians are in the audience? People from literary studies, other humanities, social scientists, quantitative disciplines? Okay, good. So social science is well represented, and in some ways the approach I'm going to talk about is, I think, more in tune with some things that social scientists have been doing for a while. I'm going to talk about modeling, particular kinds of modeling that are taking place in computer science right now and how they speak to the humanities. But actually, social scientists are also engaging in a lot of the stuff I'm doing, and doing so maybe a little more actively than we are. So I'll try to glance at that a bit. So I don't want to be too biographical, but since it's a weird talk about the interaction between disciplines, I should say a little bit about how I got into it. My formal training is in English literature, and I got sucked into this topic just because I was interested in using computer science, frankly, instrumentally as a tool to explore specific questions in literary history where we were dealing with big data sets that I couldn't read. And there are a number of people out there doing that now, and I think there's interesting work being done that has a specific literary significance if you were a historian of 18th or 19th century literature, and I'll try to glance at some of the specific literary significance. But the talk today really has a broader focus. I'm interested in the broader issue of why CS might be interesting to a humanist. And in fact, so the second part of the biographical story here is I got into it because I was interested in specific literary historical questions, but then I found myself actually enjoying reading computer science articles. And I don't fully understand all the math, but I read them for fun now. And the thing I want to address a little bit is what would be fun about computer science for a humanist. What surprised me was how philosophical a tradition it is. It wasn't how I had imagined it. I imagined it as a collection of neat tricks I could use for specific problems. But it's really a philosophical tradition, especially in some subfields, like the subfield called machine learning. As the name suggests, they're really trying to understand what learning is. We might disagree with them, whether, how far they've achieved it, but they're quite serious about that being their goal. They want to, for instance, come up with strategies of learning that can learn from the evidence that you present to them, but in a generalized way, so that they come up with a model that's not tightly fit to that particular evidence, but is capable of generalizing, capable of making predictions about new evidence. That kind of generalization is one of the things they mean by learning. Well, that's basically what we would call epistemology. It's an applied epistemological tradition that serves as the foundation for this practice called data mining, or text mining. But it's still actually a principled theoretical account of what it means to draw inferences or generalize. And while as a literary historian I find machine learning practically useful, I think in some ways the bigger news is going to be when the other shoe finally drops and humanists realize there's another epistemological tradition out there for us to be in dialogue with, for good or ill. And an epistemological tradition we're actually all using implicitly every time we do web search. This is not just something that digital humanists do, actually. If you use Google, you're engaging with machine learning in one form or another. So, and social scientists who study humanists report that, like everyone else, we begin our research on Google. So this is not of tangential relevance to humanists. One of the reasons I think we've been a bit slow to perceive computer science as a potential theoretical interlocutor is that we're so used to thinking of computers and software as tools. The tool metaphor does a lot of things for us, but I've come to think it's essentially, or at least one of the things it does, is preserve the boundary between disciplines. Asking computer scientists for a tool is a way of saying, please take your mathy techniques and package them up so I can apply them to my material. And that implies a sequence of steps where the quantitative step can be separate from interpretation. So here's your mining tool, right? You take some evidence, texts, whatever, and then our notion is that the tool serves to quantify something, and then separate from that we can do a sort of traditional humanistic interpretation. This is how I understood data mining when I got into it about 5 years ago. The notion of separation between quantification and interpretation might work for some things, but it's not really the way a learning algorithm works. And what really happens in data mining is usually you're applying a learning algorithm to generate a model. So here's a different story to tell about the process. What tends to really happen is you start with some hypothesis, something you're interested in. You want to produce a usefully simplified representation of, say, the 19th century novel. So there's some hypothesis you start with that implies an emphasis on some aspect of those texts. And then you take some selection of, say, texts from the corpus of the 19th century novel. And what really happens is learning a model that adapts the evidence to your hypothesis or fits the evidence and the hypothesis together. The goal is to fit a model to the evidence. As you can see here, there's no tool that encapsulates the quantitative stuff in a separate stage. The whole interpretive process is quantitative, but also flexible. If you started with a different hypothesis, you'd get a model of a different form. I think social scientists, as I mentioned, are a bit more used to this approach, but it was certainly new for me as a humanist. It's become possible because computer scientists have come up with ways of quantitatively modeling things that we thought were irreducibly qualitative, like collections of text. Now I'm going to briefly discuss an example, a way of doing this called topic modeling. But again, I'm not really interested in pitching topic modeling to you as we should all be going out and doing this, so much as I am conveying that this is an epistemologically interesting or maybe challenging, troubling approach. It's theoretically interesting, whether you find it useful for your research or not. So let me talk a little bit about what topic modeling is. This is a technique that's about 15 years old now. A bunch of different people were involved in developing it, but it's relatively recent. Basically, it's a way of coming up with a simplified overview of a collection of documents. Not something you would find useful if you're talking about 10 or 100 books, because you can read that. But if you've got 1,000 books, you might need a big picture, a place to start. And topic modeling can help you with that. So what you actually have are a collection of documents or books, or the documents can be of different sizes, here at the bottom of the screen. And the topic model is going to be a simplified representation that basically imagines a set of topics as if they were containers from which words are drawn to produce the documents. It's a very crude model. Like I say, at 10 or 100 volumes, human brain is going to do much better than that, the sort of notion of separate topics. With 1,000 books, though, this ends up being useful. So how do we infer what the topics are? We don't start out by making assumptions. We want to find out what topics organize this particular collection. We can't assume that each document is assigned to one topic because probably these topics are mixed up in individual documents. Words, or at least collections of 4 letters like lead and lead, are going to appear in more than one topic. They're not limited. So it's a tricky problem of inferring backward from the sort of clumpiness that you observe in the collection of documents and the way words are distributed across it. What set of implied topics, latent topics, could have generated that collection? In a moment, I'll talk about exactly how this works a little bit. I'm not going to explain it in detail. But I want to give you a sense, first of all, of how it might be humanistically useful. So let me give you some examples from collaborative work that I've done with a couple different people. This first project is from a collaboration with Andrew Goldstone at Rutgers, and he's actually another literary scholar rather than a computer scientist, but a very good programmer among other things. And this was a model we generated of the American Historical Review, the whole print run, and we divided it up into 150 topics, like as was implied in that previous illustration, where you're reasoning backward to infer a set of topics. And we treated each article as a separate document. And each point in this graph is telling you the frequency, the proportion of the whole journal that was occupied by this particular topic in that year of the timeline. And as you can see from the words that are most prominent in the topic, this is basically what we would call economic history. So in this case, the algorithm isn't telling us something radically new just by generating the topic. This is something we would recognize, I think, or I expect historians would recognize it as economic history. But it might be interesting to learn that that topic has a rise and fall over the print run of the journal. This is basically what social scientists think of as content analysis, but topic modeling can do it with somewhat less manual labor. You don't have to go through and actually code or mark up the whole print run of a journal. There are also cases where topic modeling gives you topics that aren't quite as simply what you would expect. It doesn't have to be a subject category like economic history. It can be a style, a mode of diction. If you topic model poetry, you get typically one topic that's like thee, thou, thy. People who use those second-person pronouns tend to use them a lot, so they cluster together as a topic. Andrew Goldstone and I topic modeled a collection of 7 literary journals, including PMLA and New Literary History and Critical Inquiry. And one thing that came out was not exactly a topic so much as it was a theme, or you might call it a discourse. When literary critics talk about power or violence, they do things like talk about body parts, face, blood. Actually, if you go further down the list of prominent words, eyes and hands are in the list for this topic. Now, those aren't literally part of the topic of violence as a subject category, but they're part of what literary critics do when we talk about violence. We talk about faces, blood, obviously, but eyes a little less obviously. And in this case, I think it was interesting, sort of the argument of our article, which is forthcoming in Literary History, is that this technique is useful because it can reveal kinds of historical change that aren't as dependent on prominent conflict as our other methods of historiography tend to be. So this is a very gradual change in literary history that we spend more time talking about power and violence. I don't think there was a moment in 1950 where a school of critics got together and said, let's talk about power and violence and body parts, if at all possible. On the other hand, we might remember, say, Foucault's, Discipline and Punish. And if we didn't know the longer story, we might attribute the prominence of this topic in, say, the 80s all to Foucault, when in fact there's a longer story and a more gradual transition going on. You could speculate of why what the reason is for that transition. In the article we do a bit, but since we're not all literary historians, I want to move on. I will give you one more example of some specifically literary topics that we look at in the article. These are all basically different varieties of formalism or formal analysis, and these are the words most prominent in each topic. And in this case, what we thought was sort of interesting was the dog that doesn't bark, which is that it's not the case that any of these topics or modes of formal analysis are completely displaced. At the end of, this is basically 2012, at the end of the print runs we were looking at, literary critics are still talking about style and versification. It's just that they're also talking about imagery and symbolism and figurative language, although not doing that quite as much as we did around 1965 when everything was about symbolism. So again, this is a kind of gradual change where it doesn't have to reduce to generational conflicts or a new school or a single idea or a single intervention. You can see much more gradual kinds of change. Might or might not be useful for your particular project. If it is useful, there is in fact a package out there that you can use if you do want a tool. It's called Mallet. Even sounds like a tool. And there's a blog post on a blog called The Programming Historian. That's a pretty good introduction to how to use it. There are complexities, but that's a good place to start. But I want to talk a little bit more about what kind of thing this is. I mean, this seems like sort of black magic. The computer is generating these themes for us. And indeed, it is a little bit like magic. And is going to require some thinking. So how exactly does this work? I'm not going to be able to explain it in intimate detail. It would take more than a 30-minute talk to do that. So class is dismissed. So I have to do some kind of hand-waving at this point in the talk. And what I've chosen to do is to focus on the underpinnings of the theory of learning that undergirds not just topic modeling, but a whole bunch of other data mining algorithms. Because the thing I really want to convey is that these aren't based on a particular theory of language or an account of what happens causally when people write journal articles or anything that specific. It's really a kind of generalized epistemology that's underlying them, a very general and in fact weirdly subjective kind of epistemology that quantitative disciplines are using that I think we might find interesting if we delve into it. So this is called Bayes' theorem or Bayes' rule, and if you've taken statistics, this may be a little familiar to you, but many people, I mean, I haven't, so I'm going to go over it a bit. Basically, this is a way of representing how we update our beliefs to account for new evidence. So as humanists have long known, there's no interpretation without some initial starting point, right? The hermeneutic circle and so on. So you always, in Bayesian statistics, start with some prior probability. You have some assumption about the way the world is organized. Say if my car isn't starting, I have some assumption about how likely it is to start on a given morning. About 50% of the time when I try, it will start. And that could be off a little bit. It could be 30% of it. So you can sometimes represent your assumptions as a probability distribution. I don't know exactly what the world is, but I assume that it's around 50% of the time my car will start. Then you get some new evidence, which in this equation is called a likelihood. And the point of Bayes' rule is to explain how you update your initial assumption about the world when you get that new evidence. And basically it's saying the posterior probability, the updated assumption about the world, is the prior probability times the likelihood. It's not terribly sophisticated, but it can be useful when you essentially turn it into an iterative loop and then say, okay, now I have a new assumption about the world. Now each time I try to start the car, that's more evidence, and I can use it to update my prior assumptions and turn them into a new posterior. And that's actually how a lot of these data mining algorithms work. They just do that over and over again in one way or another. To give you a sense of how that works and what makes it learning, I'm going to do a little animation of watching these probability distributions evolve as we get more evidence. And you'll see there are two different lines here, and the reason for that is to dramatize the subjective dimension of Bayesian statistics. There are two different, you start with some prior probability, some assumption about the world. what is that really? It's a belief. It's a way of modeling beliefs or degrees of confidence. So here we have two different observers. Say one represented by the dotted green line here has no idea how likely the car is to start. He's going to just assume it could be 50% likely to start, it could be not, I don't know. I haven't seen this car before. So it's sort of uninformative prior probability. Just assumes all probabilities are equally likely. And then the blue line starts by assuming that it's probably about 50% likely that the car will start on any given try. And you can see they've already shifted a little bit from the original dashed form because we've tried once in this animation already and failed. So that shifts our assumptions. We've updated the probabilities to reflect the fact that it failed the first time. And it's really just a mathematical updating process. So I'm going to just run it now to show you what happens as we keep trying this imaginary car and seeing whether it starts or not. And it will repeatedly update these different initial prior probabilities. You may or may not be able to see there's a really faint gray line here, which, as it happens, the random number generator that created this fails about 70% of the time and succeeds only a quarter of the time. So they're going to converge toward that. But in real life, of course, we don't know what the real parameters of, say, a topic are. We can only estimate in this sort of iterative way. So anyway, this is what it looks like there. And you get more and more evidence. And as you do, the distributions get a little more confident because they have more and more evidence to work on. So they're more sharply peaked, which suggests that we have a narrower range of uncertainty. And they're also converging. So what's fun about this is this an objective process or a subjective process? It's a representation of belief, and you have two different observers, and they're never really agreeing. They still don't quite agree, right? But they do converge as you get more and more evidence. It's a nice gray zone between objective and subjective. And this is actually the math that people in machine learning are using. I can't explain in enormous detail how it produces topic modeling. I mean, I could if we had time, but basically, you can imagine that instead of a single two binary outcome here, like the car succeeds or it fails, imagine you had, say, 100,000 outcomes, which are the words in the English language. Basically, what you're doing when you're modeling a topic is modeling a probability distribution over all those possible outcomes, which is more complex than just a single line, but it's still a probability distribution. And what you do is assume that each document is drawing on, you sort of imagine that as a 10,000-sided die, and there are different dies for each topic. In this die, like economic is the most common likelihood. In this one, it's power and violence. And then each document can choose from those different dice and mix them up in different proportions, depending on what the document is about. It's a simplified model. All models are simplified representations. But it's not an attempt to define objectively what's happening in language. It's a way of updating our assumptions. It's interestingly subjective. And I'm actually drawing a bit here on Alan Liu's article in PMLA last summer, which prompted me to think more about the sort of epistemological assumptions underlying topic modeling. Alan, I think, usefully directed our attention to that, saying, digital humanists are using these tools, but, what does that mean for us hermeneutically? And I think it's a really good question. I'm probably a little less anxious than Alan is. He's somewhat concerned about the fact that for him it seems like interpretation is happening in the machine. I would tend to characterize this as an interpretive strategy designed by people that runs in a machine, which might sound more reassuring, but then again, I'm not sure it should sound completely reassuring. Since we humanists haven't been in the habit of designing mathematical interpretive strategies, outsourcing interpretation in that way. If these techniques are actually useful, how disruptive is that for the humanities? In some ways, I want to say the implications aren't so big or so bad. First, because a lot of humanists will always be interested in individual books or local histories. And I'm not sure statistical modeling gives us much leverage at that scale. There's a huge desire to apply it at that scale, but I haven't been very convinced that it's useful. frankly, not because it fails, but because the human brain is good. You know, we're good at understanding language. We can do better than topic modeling at that scale. So I don't want to overstate the impact of these techniques. I do think they really work well with large collections, but I don't imagine them taking English departments by storm. On the other hand, there's a way in which saying that doesn't deal with the more basic problem that Alan raised, because it's not like topic modeling algorithms are the only data mining or machine learning algorithms we're using. I suggested that we're using them every time we open a web browser, and I think that's really non-trivially true. We call that process search, but what are we really doing? We're not just looking up the call number for Moby Dick, right? When we do a search, full text search, it's often a kind of fishing expedition for documents that may or may not exist. We're kind of doing a hypothesis. Orient jewel, if I think jewels were a significant symbol in Orientalism, and I see what comes up in a particular database or on Google. I think, in other words, we're right to worry about technological black boxes, but the big problems are search engines, which are complicated, not transparent, often proprietary algorithms that we're using very heavily in our research to rank sources by relevance to our hypothesis. That's probably significant. It's probably something we should think about, but it's become so naturalized in our practice that I don't think we do spend very much time theorizing the implications of web search. In fact, one reason I would suggest it will be useful for at least some humanists to engage computer science in a philosophical dialogue is precisely so we have the theoretical language to think about what we're doing already with algorithms in search engines. If we engage computer science in a more explicit conversation, we can not only understand the interpretive assumptions implicit in learning algorithms, but hopefully adapt them for specific humanistic purposes. The social sciences are probably ahead of us on this, but in the humanities as well, there are a growing number of collaborations with computer scientists where the whole team is working collectively on tailoring an algorithm for a specific humanistic problem. Matt Jockers and David Mimno have a collaborative article. At Texas A&M, there's the EMOP group led by Laura Mandel. At Northeastern, Ryan Cordell, Elizabeth Dillon, and in computer science, David Smith. You can sort of list a lot of these collaborations. I'm going to admit toward the end of the talk, which is coming soon, that this kind of dialogue involves real challenges. Among other things, it may require kinds of training we're not offering yet. And it may raise questions of access we haven't solved yet. For now, let me just concede there are problems. But I'm not very worried by the problem that seems to worry people most, which is the notion that collaborating with quantitative disciplines will turn us into unreflective empiricists. I've tried to argue that people in CS to begin with aren't unreflective empiricists. Bayesian statistics is actually kind of interestingly subjective, interesting epistemology. But also just, concretely in terms of my own experience, collaborating with David Bannon in computer science at Carnegie Mellon, we're working together right now on a model of literary character, which I'll give you some snapshots of in a moment. But just anecdotally, my own experience with that was that I in the past had been mostly historical in my interests, but the instant I tried to describe literary character for David so that he could help us model it, the first thing I discovered is that I don't really have a good understanding of what literary character is. And in fact, it's a deeply conflicted topic in literary studies. So it forced me, in fact, more toward theory and less toward kind of empirical historicism than I had previously been used to. For instance, I discovered that there's a long-running debate. Maybe I should already have known about this, but like I said, I had been doing historicism. Long-running debate about whether characters can be even understood as representing imaginary people, as essentially representative, or whether they should be understood as formal and structural features of narrative. If you look at fairy tales, Vladimir Propp has a strong argument that characters are basically narrative functions. On the other hand, if you look at realistic novels, they sort of feel like imaginary people. On the other hand, sometimes you get the same character in two different books, but in one book, say Huck Finn is a first-person narrator, and the other is a third-person character. Are those similar characters or different characters? Depends on whether you're thinking representationally or formally. Formally, first-person narrators are very different from any other kind of character. So trying to come up with a model of a phenomenon like character can actually make us realize how little we understand about it. And I think that's often the most important contribution that humanists can make to quantitative disciplines, is to remind them that the fact that we have a word for something doesn't mean that there's a clearly defined concept there, like character or influence. You know, that you have people out there trying to model influence in literary history. Do we really know even what we mean by that? Those are questions that we're good at raising. But sometimes the task of trying to model a phenomenon is what helps us raise those questions in interesting ways. And in fact, I think that's probably the real value of things like this for the humanities. It's less that it produces slick visualizations or slicing big data sets, and also that it helps us discover that we're sitting on a trove of really interesting questions that we could be pushed to formulate better. So I want to end by talking a little bit about the specific collaboration with David Bamman, and then I'll glance at some of the sort of social challenges of helping humanists do this. David is actually a grad student, an extremely well-published grad student in computer science at Carnegie Mellon. And there's a lot of overlap in the Venn diagram between us. The literary impulse of this project really comes from him. He was trying to model character in film, in plot summaries of film. And I said, that's a good idea that I would like to try out. And offered to collaborate. And so now we're doing that with 18th and 19th century novels, mostly 19th century, because that's where the database is strongest. So, how do you actually model character? First of all, you have to get the novels, and that's actually tricky, and more tricky than I'm going to have time to acknowledge here. You have to clean up the data in some cases. So I take care of those stages. Then what David does is, using what's called natural language processing, he splits the text of the novel up in words that are associated with different characters. So, if a character with a particular name does things, the verbs that represent doing that thing are associated with that character. If it says he went, he then went, he tries to track he back to the character name that it's associated with and associate that word with that character. So we end up with, again, sort of bags of words that are associated with characters. But we also know, were these things that they did, or things that were done to them, or things that they possessed, or things that were said about them. And we have this on about 600,000 characters from 15,000 different narratives. So being a literary critic, I know that representing characters as bags of words raises dilemmas and makes literary critics tear their hairs out, tear their remaining hair out. And no, this isn't going to help us understand, the dark heart of Captain Ahab better. Again, this is a kind of simplified model that is probably only useful at scale, addressing problems that we wouldn't otherwise be able to grapple with. So not so much, what happened at the end of the turn of the screw and what were they really doing, more what's the history of the Byronic hero? Is there a rise and fall? That sort of scale. And the collaboration is still in progress, so I'm not going to present results, and I'm also not going to worry too much about this diagram. I'm going to skip right over it. But I do want to give you a couple snapshots of things we're beginning to see. So we have 15,000 stories, and break that up into about 600,000 characters. And this is just looking at the third-person characters, because among other things, as I'll explain in a moment, I want to be able to identify gender here. And you can do that more easily with third-person characters. And our goal is partly to tease apart, as I was saying, different formal and representative dimensions of character. But in this case, we're looking at a simplified model. David has a more complex model. This is a simpler one that I was using that doesn't really attempt to distinguish formal and representative facets. It just treats those words essentially in a topic modeling fashion. And in this model, we broke all the characters up into 50 facets that might be represented in different characters to different degrees. And one of the interesting things you see is that there are some facets of character that aren't really gendered at all. They're essentially represented in the same way in male and female characters. They may increase steadily across the timeline or decline steadily across the timeline in the same way for characters of both grammatical genders. We know gender because pronouns in English, he, she. We have at least that kind of gender. And then there are some topics like this one where it's very much more strongly represented among men, especially early in the period. And this basically confirms a thesis that literary critics will be familiar with, which is a division between the public sphere and the private sphere, a gender division between those spheres. This topic, as you can sort of tell by looking at the words, tends to be more associated with public life, followers, people, majesty. Maybe it's specifically military. I wouldn't be surprised if a lot of these stories are by Walter Scott. But associated especially with male characters. What's a little more interesting, I think, is looking at the ones that are associated with female characters. You do see ones that are associated with the private sphere in the sort of sense of domestic realm, family, and so on. There are other topics like that. But this one is a little more interesting because you might characterize it generally as subjectivity or interiority. You could say sensibility. There's feelings in there, but also mind, eyes. It looks a lot like subjectivity to me. And what seems to kind of confirm is Nancy Armstrong's influential thesis in Desire in Domestic Fiction, that subjectivity and interiority were, to begin with in the novel in the 18th century, more strongly associated with female characters, and only gradually did novelists become as interested in them in men. At least here, we have a lot more of this topic in characters, in female characters. Now, to really talk about this, we have to back up and look at the whole model, because there are other topics here too. It's a complicated story that you can't tell just with one topic. What's really happening here is that the significance of this topic is declining. So that doesn't really tell us that it's becoming less gender-coded. It tells us that some other topic is taking over. And we have to look more at those topics to see what the history is later on. But it's at least, I hope it gives you a sense of why I think this kind of thing is potentially interesting. And in fact, I'm going to just stop and summarize it briefly. What I found surprising, I started this about 5 years ago, and basically I thought, okay, the interpretive part of this isn't going to change. I'm just going to go over to computer science, borrow some quantitative tools, which will let me count words. And then I'll do what I pretty much have always done. But the more I've thought about this, the more I've discovered that, in fact, counting words is something we started doing in the 1990s with large data sets. And in fact, every time we use a search engine, basically we're doing quantitative data mining. That's not really the new part. The new part is for humanists to think more explicitly about modeling strategies and learning algorithms, and to think about what that does to our interpretive process. At least that would be my case. So, people talk about data mining in a way that suggests it's sort of the rise of the machines, but my version of the story would be that the machines rose in the 1990s, and we're just now beginning to be theoretically reflective about what we're doing with them. The final thing I want to say, just as a conclusion, is just to acknowledge the problem of training and access that I gestured at, and I'm not going to do much more than gesture at it in conclusion. But I do think that it is urgent, actually. In practice, what we've been doing so far, people are interested in digital humanities. There's a lot of discussion of what that means. But in practice, we're largely relying on extracurricular background for people to actually do this. We don't have, at least at Illinois, we don't have a clear curricular path to train grad students how to do this. I had a sabbatical, so I could retrain myself. That's how I did it. And there are a lot of problems with that, but one maybe not quite obvious problem is that extracurricular interests are not evenly distributed. People have different kinds of extracurricular interests. And if these opportunities are significant, and if we were serious about distributing them equitably, we need to come up with some system so you don't have to have had a past life as a computer geek to be able to do it, which frankly is, I had a past life. So I mean, that seems to me urgent, and it's not a problem that I've successfully solved, or that we've solved at Illinois, which is why I'm not going to spend more time talking about it, because I don't actually have a clear solution. I think it's going to depend on institutions. But I do want to acknowledge that as important. And in fact, I'm interested in hearing about how you guys might be solving it here at Kansas. So thanks for bringing me, and let's open it for discussion.
To this last point that you were talking about, the kind of training needed, how much training do you think an individual still needs if you're also just going to be collaborating and really close?
Yeah.
Is it enough to have just solely humanistic training and then find your perfect match on the computer science side, or is there really a necessity for some cross-training? It sounds like you think there is, but I wonder if you could speak to that.
I skimmed, that's something I abbreviated. In some other versions of this, I've said more about it. You know, these are interpersonal relationships, so it's going to depend on, perfect match is actually a nice phrase. It actually feels a little bit like that. So when I talk to other humanists, computer scientists, I feel a little bit like I'm cheating. You know, or there's something a little illicit about that. So it's an individual problem. I will say that in the relationship I have, in our relationship, I would feel that I wouldn't feel that it was a fair distribution of labor if David was doing all the coding, because there's a lot of grunt work to do. Like, I just glanced at the problem, cleaning texts up and figuring out which of these texts are actually novels, which is not necessarily straightforward. And so I can take some of that grunt work. Otherwise, I think it's a bit like, it would be a bit like a social scientist coming to an English department and saying, I'd like to collaborate with you, and I hear you guys are really good spellers, so could you do all the writing? I mean, you know, computer scientists don't specialize in programming as such. It's more the techniques, modeling and so on. But that could be different. There could be, you know, specific institutional circumstances where that's not important.
Or with sufficient graduate students or to do the really, really grunt work, but using the intellectual powers to decide what is the grunt work, and giving each other enough of a tutorial about the languages that you're speaking from a particular perspective, so that you can come up with new ideas that you wouldn't have otherwise.
Right. That's the other part of it that's important is, you know, David and I can have a conversation and say, like, okay, I think that part of the model is not a safe assumption. And for that, we have to both understand a little bit about literature and a little bit about statistical modeling to have that conversation. But that's interesting, but less time intensive than, you know, learning to program. And you're also right that grant funding can smooth things out. If it's out there and if it allows you to hire staff programmers, that's wonderful. That's a longer story, though. It's not always out there. Yeah.
You were talking about originally you were sort of interested in the tools that this collaboration sort of grew out of. You're thinking, well, you know, we'll have cooler ways of coming up with some of these things. And what I was wondering is, from your perspective, it sounds like that's a good impetus to at least have started. What was the impetus of your collaborator to work with you?
Computer scientists do this, actually. I don't think they all share this attitude, but I've known a number who, they sort of think of their discipline as anthropologists, where they go out and try to understand the problems that other disciplines have, because they're really methodologists. They don't have a single defined subject matter. They're interested in understanding interesting problems so that we can come up with really cool ways to address them. So certainly, you know, in my experience, David is really good at that. He was very good at asking, you know, what are the parts of this that are really interesting? Where are other people in your discipline on these issues? Is there a theoretical debate that we can hook this up to? And, you know, it happens that I think David has a background in the classics, and he was a classicist working on the Perseus project. So, but there's a lot of computer scientists who think that way. So they do have a motivation to find interesting problems in other disciplines, as long as that doesn't mean, unreasonable amounts of grunt work. So for instance, if I hadn't been willing to deal with the data end, what would have happened is what computer scientists often do. They work, or computational linguists, they'll work with Gutenberg texts, which aren't really, you don't really know what version that is, and they don't represent anything in particular, because there are a lot of science fiction, because who likes to digitize text? People who like science fiction. They don't represent the 19th century, say. So, but they're easy to work with, though, and the texts that I wanted to work with were more historically representative, but harder to clean up. And it was really only fair to do that if I was going to do the cleaning up.
Well, I'm interested in a lot of these same topics, although with Russian and Russian novels versus English. And I'd be curious to hear your thoughts on how this methodology might translate to a different working language and what resources are available or difficulties in that.
So, topic modeling itself is sort of language agnostic in principle. And the methodology we're using is sort of an adapted version of topic modeling. It makes slightly different assumptions. The things you'll deal with concretely are things like, often you need a list of stop words. You may...
And they don't exist for Russian like they do for English, so...
But that's creating a list of 200 common words. What's a little more complicated, okay, so if you're topic modeling fiction, stop words are common words that you take out, just basically because you just don't want to see the, a, and, because they're not informative. When you're topic modeling fiction, you have to broaden that a little bit, because the other kind of arbitrary word you get in fiction are personal names. So if you don't take out, Eleanor, Elizabeth, you will see topics that are all the novels that have a character named Elizabeth. And so there's a little bit of that kind of cleanup thing, but in principle, it's not that. What might be tricky is if you want to do the kind of thing we're doing where we actually identify what words are spoken or associated with different characters. That's language specific. And if they don't already have the Stanford natural language processing tools trained on Russian, someone would have to train them on Russian. But topic modeling itself can be done.
So that does lead, you mentioned the Gutenberg project. How do you find these? They have to be digitized, I assume, or not. So somehow these things are digitized and readable, and where are you getting access to them?
HathiTrust Digital Library. Yeah, I should have credited them more prominently. And in particular there's a sort of a researcher-focused subset called the HathiTrust Research Center, located, in fact, at Illinois and Indiana, but it's meant to serve everyone. So those are optically transcribed texts, and that's why I say they need some cleanup. So if you go back into the 18th century, Finger and Singer are indistinguishable sometimes because the long S looks like an F. But those things can be cleaned up, actually.
Well, I've heard of some projects that scholars have made deals with, like Elsevier, for permission to mine data of, now that's not fiction per se, let's say, but I wonder if those types of other kinds of tools, other aggregators of...
For like secondary literature, Andrew and I used, JSTOR has a data for research service that will give you, most journals all journals that are in JSTOR in a way that you can use for topic modeling. If you wanted, more specialized stuff, you might need to make a special deal, or, there are proprietary vendors out there that, I know at Stanford, they often have been able to make a deal and get some proprietary data, which is great. But you don't necessarily have to do that for like journals or 18th and 19th century books up to 1923. Beyond 1923, the interesting thing about HathiTrust Research Center is they have the goal of opening stuff that's post-copyright, stuff that would be under copyright They can't distribute texts of it to us. But what they can do is sort of tell us data about the book, like how many words, what words appear on this page. I can't tell you what order they're in, but I can tell you what words are there. So for this kind of thing, that would work. And hopefully, they hope to be able to do things that are more subtle. Like if a bag of words method is not going to work for what you want, you might be able to design a tool and send it in to Huntington's Research Center.
Just wondering about topic modeling and poetry.
Yeah.
I mean, there's a way in which this project reflects our interest in prose and our historicizing.
Yeah.
But looking at that graph of what people were doing in the 60s, the symbolism made me think about
Poetry. Yeah, and versification was in there.
Versification, yes.
Yeah. That is an interesting debate. That has come up a couple other times that I've given the talk. Mm-hmm. And I think it's still an open question how this will work for poetry. I should point to Lisa Rohde, who's done a project, Topic Modeling Poetry, that she presented at the MLA. And she's specialized in that more than I have. And she connects it nicely to some close readings of particular poems. My sort of, historicist, bent on it, or the experience I've had is that it's not as different for poetry as you might think, because a surprising amount of the meaning of a poem, or even the sort of poetic quality of a poem, can be contained in word choice. And actually, this is something we've long known, the importance of diction for poetry. And word choice works surprisingly well for topic modeling. I think I'm acknowledging Lisa Rohde because she has a different opinion about the way poetic language works. So it's going to be an interesting debate.
Well, and it occurs to me too that, novels vary in length.
Yes.
But not like poems do.
Yeah.
Right? In terms of line length, right? Just in my own field, the Dickinson versus Whitman kind of thing. How could you topic model for poetry that is so inherently different?
Yeah.
Even when it comes to word choice, just the verbosity of one concision.
Yeah. Deciding the chunk size that you use for topic modeling is one of these places where there's this kind of a little wheel you can spin with subtle implications. But which doesn't negate what you're saying. You would have to make some choices about that. You could break it up poem by poem. You could break it up stanza by stanza. And that's going to be hard to generalize.
Has topic modeling made its way into your teaching?
A little bit, yeah. I have tried it in, I taught a grad seminar that was sort of generally about the whole area of digital humanities. And we looked at it in that context. And it did generate some articles that have gotten published. So I was pleased with that, actually. And I've tried a little bit at an undergraduate level as well, although it's harder at that level to work in, but it was an honors seminar. So I think so. I can also envision, at Illinois we have a strong school of engineering, computer science is very strong, so we may end up teaching writing to computer science students, and it would be nice if in that context they could be doing something that's literary, a little away from their home turf, but maybe also interesting to them in their own disciplinary ways. So I can imagine doing it in that sort of course.
Has the university been thinking at all about, and also in response to your kind of closing question about collaborative learning in that context, so that humanists
could participate.
Graduate students in a humanist discipline would be going out and working with people in the fields who could help train them.
Right. I've seen. I haven't taught that kind of course yet, but I've seen some where the goal is explicitly to get a mixture of students from different disciplines, like computer science and humanities, working together on thinking about social media and from a social or historical point of view, but also what can we do that will actually give us a grip on what's actually happening in this mass of information. So I've seen some specialized courses like that, but we don't have it institutionalized, and it could be hard to institutionalize. But the other place where this is happening, frankly, is we have the Graduate School of Library and Information Science, which is trains people who work in libraries, but also in a lot of other circumstances. And it's kind of been the institutional home for digital humanities at Illinois. And it's got a mixture. The people there are humanists, but also social scientists, and also with a CS background. So it's, in that kind of institutional context, they're mixed up. It's a little harder in the context of an English department or a history department to, there you would have to explicitly design a kind of interdisciplinary course.